home stretch. Right, so we have our frequency density, and that goes up to 23.6. So we need to use a sensible scale. I would probably take this as every 5. And then we draw our, oh apologies, this pane has been on a different page. So 2.6 from 145 to 155. So 145 to 155 is 2.6. So if this is 5 units, then each 2 squares is 1. 1, 2 point, oh, I forgot what it was already. 2.6. So it's about there. Oh, that was badly drawn. Yours would be much better. 13.2. There. Beautiful, Mr. Harrison, well done. 16.4. $23.6. And then as I recall, this one is also 13.4. Obviously you are using a ruler for this, I am not. 1.73. 1.73 is about there, and that was 175 to 190. I think it was 190. Yep. Okay, so your histogram should look something like that. Last question. So this is all on calc. On the diagram, sketch the graph between -1 and 5. So we need to stick this in our calc. So that's 3 plus 1 over, oops, x squared minus 4x plus 3, and change our window between -1, 5, and our y-axis goes from -3 to 8. And then we copy this picture. Now, I was quite harsh when I marked this, simply because I think they will be in the final exam. You can see that they then actually go on and ask you about asymptotes. Now we know that asymptotes are features of the graph where there are impossible values, which means that you can see that they are likely to be there, there, and there. That means that these portions of the graph cannot overlap at these places. So you have to keep them separate. Now, far too many people were drawing their portions just willy-nilly. Try and make it look as though the graph, as the graph did. Even separate this into 1, 2, 3, 4. 1, 3, 2, 4. That was a bit badly done. And then that's 4, 2, Okay, if that helps. And then you can see exactly 1, 2, so it's just over 3, and it's a scoop up. 1, 2, 3, just over 3, and scoop up. Just past 1, but before 3, and doesn't go anywhere above 2. Is that what I'm supposed to say? Oh, apologies. It should be less than that. And these are the kinds of things I'm trying to get you to think about. And then this last one is similar to this one, but is there. Okay, so we've left these areas here not overlapping, and we've left this area here blank as well. It doesn't have to be perfect, but just try and make it look as good as possible. Write down the equation of 3 asymptotes. Well, as I said, hopefully you can see it's here and here, so that's x equals 1, x equals 3. And the reason for those is because these two values would make this equal to 0. Because if we factorize this, we would have x minus, 3 and x minus 1. Okay, that's where we get that from. And the horizontal asymptote, well, hopefully you can see it's across here, and that's y equals 3. And we can also tell that from this value here, because the graph shifted up 3 units, and the horizontal asymptotes normally along here. So that's those points. Find the coordinates of local maximum. So this is where we do calc. Maximum. Hoping you can see it's there. So left bounds a little bit to the left, a little bit to the right, enter, and you can see it's at 2, 2. The line y equals this intersects the curve 3 times. Find the values of the x coordinates at those points. So we can now also plot the graph y equals x. So we need to find these 3 places. So calc intersect first curve, second curve, guess. So it's a we just need to know the x value, so that's 1.38. Whoa. Second one, second calc intersect first curve, second curve, guess. 2, 2, so x equals 2. And the third one, second calc intersect first curve, second curve, and guess, and 3.62. Done.